In the build, we learned how to build a rocket and how to calculate the CP and CG of a 2-liter bottle. This can be proven because our group made rockets, and when we shot them in the 45 and 90 degree launches, they flew perfectly. This is also shown because if we had an incorrect CP or CG, then our rocket would have rotated in the air and landed somewhere tangential to the rocket launcher. This lab would be useful if we wanted to make a bottle rocket for a physics class in the future, or if we got a similar or even the same lab in college. Also, if you decided to be a physics teacher and wanted to do more of a hands-on lab, this lab would be the perfect lab to do so. Knowing this information could also help you while hunting or practicing shooting a gun or bow and arrow. We also use a few formulas in this lab, which are circumference, which is pi diameter, the CP, which is 90% of a 2-liter bottle, and the TCG, which is 80% of a 2-liter bottle. If we were to get perfect results next time in this lab, we'd have to use better technology to make the cuts for us and measure everything to create 4 completely identical rockets. Also, the rocket launcher would have to have a countdown where it could be programmed to shoot at the exact same time every time. But the last thing you have to do to get perfect results is to remove all outside vectors like wind, temperature, water loss, and angle at which the rocket was fired at. Our group worked well together during the build, and we each did separate parts of creating the rocket, then brought all of our parts together where we made the 4 identical rockets at the same time. We also checked each other's work to make sure we did our part correctly. What we liked about this lab was being able to build something and use what we built to continue on in the lab. If we screwed up any part of the build, then the rest of the lab would be screwed up as well, and puts more pressure on building the rockets correctly. The other thing we didn't like about this part of the lab was that we wanted to shoot the rockets, and we had to do this before we could actually have fun. The lab that everyone in the group could compare this lab to was the rocket lab that we had in 7th grade, where we made rockets and fired them into the field, but with no true reason behind it. In this lab, we did calculations and actually determined how far they would go, instead of just firing them for fun. In this lab, we had to be precise as well, so that it made it a little different than the lab we did in 7th grade. We would definitely keep this lab for next year, because you have to do this to be able to have the fun in the other labs. This is one of the hardest parts of the lab, so it prepares the group to do work and focus on being precise. Boom.